In this video, we'll start by talking about how to solve trigonometric equations. Now, this is going to be part one of a series. There's going to be a few of these because there is a lot of nuance here. So we're going to start with just one, try and simplify it a little bit because there's a bit of a stepping stone here, a little bit of a learning curve, because this is a little bit different than solving linear equations that we've talked about in the past. So we'll talk about this, and it'll be the first part of a series. I think the best way to start would be to look at an example, and then we can kind of go into the theory a little bit as we go. So let's say we're asked to solve this equation, cosine of theta equals the square root of 3 over 2. Now what this is really asking is, okay, if I'm on a unit circle on the coordinate grid, and remember, all trigonometric functions are based on the unit circle, and if we're looking at cosine, that tells me my x-coordinate is square root of 3 over 2. And that would be positive. So we're going to move to the right, however far square root of 3 over 2 is. And we're going to look at, okay, what angle is this? So let's just start there. If we're looking at it, what it's saying is that our x-coordinate is square root of 3 over 2, the base of our triangle. Now, if we think about this, we can use our inverse trigonometric knowledge. We could say theta equals the inverse cosine of square root of 3 over 2, which, if we're using degrees, that would be 60 degrees. So that would tell us what this blue angle is. Now, the only problem with this is that may not be the only solution. There's another angle on here that has that same x-coordinate. If I drew my triangle a little bit differently, that also has an x-coordinate of square root of 3 over 2. It has the same base. Now there's a couple ways you can go about finding this angle. You could think of it as, okay, how would it be from here all the way around? Or, in the case of cosine, you can think, okay, what would that be? Now, very similar thought. We can just say, okay, well, this angle, magnitude-wise, is 60 degrees. That much hasn't changed. We're talking about congruent triangles here. So, two thoughts on the yellow angle. We can say this is negative 60 degrees, or theta is equal to 300 degrees if we're thinking about the positive rotations. This would be the first angle I drew in green here. If we were to think about it, okay, how can I get all the way around starting at the origin with a positive rotation? And then this also begs the question, okay, say I spin this around, let's look at the original blue angle, let's say I go all the way around and cap it again. So instead of 60 degrees, I could be looking at 420 degrees. Since they're coterminal angles, they end in the same spot. There's a multitude of answers here. You can have many, many solutions. So what we're really defining here when we're solving for theta is a solution set. So if we're looking at cosine of theta equaling square root of 3 over 2, we could say theta is equal to a few possible things. The first being the 60 degree possibility that we talked about first, plus or minus any multiple of 360 degrees. If I was to go all the way around the circle, however many times after 60 degrees, well, I'm still stuck at that spot. Where n here is an integer. Okay? And then, very similarly, we could say use either the 300 or the negative 60. In this case, I'll use the negative 60. Again, plus or minus any multiple of 360 degrees. Now, if you'll notice, if I was to take negative 60 and add 360 degrees to it, there's my 300. So that one is covered here. So ultimately, we're defining a set in our solution. There will be more than one possible answer here because the only part that matters is that on the theoretical level, where is my x-coordinate equal to the square root of 3 over 2? Now, if you're solving for a sine, you would not be using x, you'd be looking at y, because sine would be y on the unit circle, and we've talked about that previously. This was part one. We'll talk more on the next piece about what to do with tangent and cotangent, secant, cosecant. That'll be kind of more of that piece. For now, we're sticking with sine and cosine.